Brian Lowe with Belleson LLC here again to talk with you about ripple rejection. In our prior video that discussed ripple rejection, we gave a number of examples and we were showing the rejection at 1 kilohertz. It turns out that 1 kilohertz isn't the best place to look because typically you'll be wanting to reject power line frequencies or double power line frequencies in the case of a full wave rectified power supply, or something in a very high frequency, maybe, I don't know, tens of kilohertz or hundreds of kilohertz, maybe if you have some digital signal that's running around that's affecting the power supply. So I'm here to give some additional examples using a ripple rejection frequency of 85 hertz, which is a little higher than both the US and the European UK standards of 50 and 60 hertz, and a little lower than double those frequencies, which are what would be happening on a full wave rectified power supply signal. But it's a good example that shows what's going to happen at a lower frequency and somewhere in the range of power line frequencies. So the first thing we have here is an LM317. So I'm going to zoom in so you can see it better. And this point is 100 hertz. So you can see just below that is the signal, and this is the rejection. Or this is actually the signal that's coming through, would be a better way to put it. So the feed through signal. So if I turn a cursor on and take a look where that is, I'm seeing about minus 68 dB on this cursor, which is not particularly good for power line frequency rejection. Now I'm going to switch it out and put in a different regulator, and we'll see what that one does. But I wanted to start with something that wasn't quite so good so that we could actually see that there is some signal that's potentially going to get through. Okay, now you can see an LT1085, which is significantly better than the LM317. If we drag the other cursor down, I can compare, and this, instead of being at minus 68 dB, is at about minus 85 dB. So that's significantly better in terms of power supply rejection for the LT1085. Okay, now we have the LT3080, which, as you recall, is a really good monolithic regulator. And you can see that the noise is significantly lower, such that not only can we see the 85 hertz signal that's coming through, and I can move the cursor again and see that that is at the level of minus 98 dBV. And then you can also see with the lower noise that there's some 60 hertz embedded down in there that wasn't visible from the with the other two regulators that we've looked at so far. So again, a significant jump in performance, minus 98 dBV. Okay, this is a TPS7A4700, which is a nice low noise monolithic regulator. Turns out that this one is hardware programmable by tying particular pins low or high. So this one's set up to be approximately 12 volts. And you can see that the ripple rejection at 85 hertz is a little better yet, and there's no 60 hertz showing through. We are at, let's see, minus 101 dBV, which is a slight improvement yet. Now this regulator has some interesting characteristics that we're going to look at in a little more detail when we do our video measurements on output impedance. However, it does show some really nice characteristics in terms of noise and ripple rejection. Now we're looking at the LT3045, which is also a very nice low noise regulator. However, you can see that there's a relatively higher amount of ripple getting through compared to the TPS 7, whatever it is, TPS 7A 4700. And this one is, instead of minus 101 dB, it's at more like minus 93 dBV. So a little more of the ripples getting through. Now we're looking at the Sparkos regulator, which is a very good regulator, as I mentioned in the earlier video. You can see that at this resolution level, there's nothing getting through that's more than noise in terms of ripple at 85 Hertz. So very, very good performance. And here is the SPZ78. Once again, very much like the Sparkos, very much like the Sparkos, there's essentially nothing coming through at 85 Hertz. So again, a very, very good performance regulator for ripple rejection at power supply frequencies. Also notice it's nice and clean with low noise. And finally, the teaser that I brought up in the last video. This is the newest, latest, and greatest regulator out of Belleson, which once again has no visible signal ripple coming through at 85 Hertz. So stellar performance once again. And with that, you can see why I initially wanted to have some regulators that didn't perform quite so well, because maybe you wouldn't believe that there was actually the potential of ripple getting through because you can't see it at 85 Hertz. And that's one of the reasons that we were originally looking at the 1 kilohertz signal, because regulators tend to not be as good at higher frequencies as they are at lower frequencies. So I knew that there would be something visible for all the regulators at 1 kilohertz. However, as you can see, the highest performing regulators are showing certainly below a microvolt, or in the microvolt range of ones of microvolts of ripple, which is right there within the noise levels. And that's all we have for you. We hope you enjoy the information and can use it to your best advantage in whatever way you choose. We hope it's been educational. Good luck with your projects, and remember Belleson, super@belleson.com.